Hey, Nathan here, welcome back to another video for the PGL2D Alpha series. And in this video we are going to look at the BaseScreen class. So let's bring up the Solution Explorer and right click Screen System and go to Add Class. We're going to call this BaseScreen. I'm going to close the Solution Explorer, make that very small. Okay. So this is going to be a public abstract class. So it's going to be abstract because we only want to allow derived classes of BaseScreen. So the screen itself is actually going to be an entity. It's just going to be a container that holds game objects and text objects. But it's going to be an entity in that we can control if it's active or frozen or hidden. It's going to have initialize and updating and drawing, so it's going to be an entity. So this is going to drive game entity. Then we need to add using PGL2D.game object in this. Alright, so let's get started with the properties here. The first property we are going to add is a property that will determine if the screen can accept input. Let's take, for example, we have a loading screen or a transition screen. A loading screen, in our case, will just display now loading, please wait. It might have a little animation to indicate that it's still working. However, we cannot press space or enter or escape or the arrow keys. We cannot do anything. We cannot use the gamepad. We cannot hit any buttons on the gamepad. We cannot use the mouse. We cannot hit any buttons on the mouse or move the mouse around. It will not accept input. So we need to have a property that determines that. Public bool accepts input. And that's going to be get and private set. Get and private set. Okay. The next two things we want to add is they are both going to be Boolean state values that determines if the content has been loaded and if the content has been unloaded. A brand new instance of BaseScreen will not have content be loaded, and a brand new instance of BaseScreen will not have content unloaded. You cannot unload content before it has been loaded. So both of those values will be initially false. When we load all the game's content, we'll eventually set that content loaded to true. And then if in a future game or a future extension of that class in this PGL2D library, we're going to query that content loaded Boolean value, we have that chance to do that. That gives us the option to, if we want to determine, hey, we just want to check to see if the content has been loaded on this screen. Maybe you want to load it in a background thread, and you'll have to do additional work in the background other than just using that Boolean value. But just for simplicity's sake, if you want to load that screen in the background in a different thread, and then once it's done, you want to load it into your game, only if the content has been loaded. So you check to see if screen.contentLoaded is equal to true, I'll add it to my game. Otherwise, I'll throw an exception or throw a message to the user or retry to load the screen or whatever your exception handling is for that case. So these are the two values we're going to use. Public bool content loaded and public bool content unloaded. They will both be get and private set. So I'll just copy and paste that. The next thing we want to do, we want to have a property that will handle the input mapping just for this screen. A menu system, for example, this isn't for every menu system. For an example, a test scenario, a menu system will only support the up and down arrow keys. we do not need to have an input map for the entire game. That's entirely possible. If you want to do that, you can change the PGL2D library to fit your needs. If you want to keep things separate, you can follow it this way. In this case, the menu system only allows the up and down arrow keys. There's no reason why we need to add more things to the input map. So we are going to have an input map in this class. And then we need to add using PGL2D.input. The next thing is kind of something that I went back and forth of how I wanted to implement this. And I'm probably going to change this in beta and the final release now that I think about it more. But for now, they're two separate things. These two properties are going to hold our entities for our game. The main list is going to hold our game entities when we are referring to sprites and power-ups and game objects. The other list is just going to be game entities where we look at text. What is displayed? How much health you have? How much time has elapsed in the game? What's your score? All those text entities are going to be contained in their own list. Now, I will probably combine those into one master game entity list, because at this moment, text entity derives from game entity. Those are going to be protected access level, and they're going to be list, and it's going to be protected, but the access is going to be get and private set. So I'm going to go ahead and create those. We need to add using system.collections.generic if that is not on your list. Okay. Those are our properties. The entities, that's where, if it's not text, it's going to be in the entities list. Sprites, power-ups, enemies, platforms, whatever. Anything that's not text and it is a game entity will be in this list. Again, it's protected and it's get and private set. Everything that is text is going to be in this list, and it's just a list of text entities. That's the same thing, protected access, get, and private set. All right, let's go ahead and work on the constructor. So the constructor is just going to be accepts input. That's brand new. But this is a derivative of game entity, which provides is frozen and is hidden. So we can actually create a base screen that is initially frozen and hidden to the user. But we will default that to false. And we're going to make this constructor protected. There is no way we want anybody to add a instance of base screen. Protected base screen bool accepts input. That is not going to be optional. You have to say yes or no that this screen accepts input. Bool is frozen is equal to false. It will not be frozen by default. Bool is hidden is equal to false. It will not be hidden by default. So accepts input is equal to accepts input. Is frozen is equal to is frozen. Is hidden is equal to is hidden. We're going to set this to false. We just created the screen. We don't want to request it to be deleted already, so we're going to set that to false. Input map is equal to new input map. Entities is equal to new list of game entity. And text entities is equal to new list of text entities. Okay, so that is it for the constructor and properties. There is no private fields in this class. Next, let's discuss the load and unload content. And in between that, we will discuss the terminate method as well. So let's get started with the load content. Public void load content. It's going to be parameterless, just load content. And that's going to call, this is a base screen. It doesn't know what you're trying to load. One game screen, your loading game screen, might only load a picture file for or a sprite sheet for the animation that will be used for the loading animation. And it will also load the sprite font to display the text that says loading, please wait. But in your actual gameplay screen, you're going to have to load your player, your platforms, if it's a platformer, your power-ups, all those things. And in one game screen, it could be a different set of enemies and other entities than another game screen. So at the base screen level, we don't know what you're going to load, but we want to do this in the correct order. So this is going to use the template pattern that we call one method and guarantee the next method is called after that. So we're going to call load entity content. Now we did not make that yet, so that's fine. After that's done, we're going to call done loading content. We didn't create that yet, but that's fine. Load entity content. That is another thing that is kind of a tricky situation. Load entity content. We're pretty much going to guarantee that every screen is going to have to load at least one thing. It's going to be an exceptional case where you create a game screen and you don't load anything. It's just going to be a blank screen. That is going to be very, very, very rare. So I chose to make this an abstract method. If you have other needs, you can make this virtual and just make it a emptyless method body. Just empty. That way it's not forced on the classes that you derive from BaseScreen. It's going to be protected because we don't want outside sources to call this. So protected abstract void load entity content. All right. So if I make a derivative of BaseScreen, I have to implement that method. It's going to be, unless I make another abstract class in between. It's going to be extremely rare where I won't load any kind of content. I'm going to have to, I might just load one piece of text. So I'll need to load a sprite font. But it's going to be extremely rare where I don't load anything. Now this is going to be virtual. Protected virtual void done loading content. And all that's going to do at the base screen level is just going to set content loaded is equal to true. Okay. Next, let's discuss terminate. When your screen terminates, it performs some cleanup. It unloads content if content needs to be unloaded. It will set itself up to be requested to be deleted. It will set that property to true, and that will notify the screen system because it will query that property every loop, and it will notify, hey, this screen needs to be deleted, so I'm going to go ahead and remove it from this list. And then we're going to call base.terminate because that's an actual method from game entity. So public override void terminate. So terminate. We're going to call unload content, which we haven't made yet, but that's fine. We're going to set this to request deletion is equal to true. and we're going to call base.terminate. Okay, now let's create that unload content. Now you might be thinking, all right, well, we did load content this way, so unload content will be similar. That's not the case. There's a cool trick that we can do. Protected. This is going to be protected virtual. So we're going to have some code in this already. Protected virtual void, unload content. There's a trick we can do. We have a list of entities, game entities. Anything that derives from game entity is allowed in this list. One of those classes we have made, and it's called physical entity. And physical entity has content that can be loaded into it, texture 2D. So this is the trick that we can do. For each, var physical entity in entities.ofType. Physical entity. What we are doing, we are looping through every physical entity in our entities list because it's getting that list of type physical entity. So every physical entity in this list, we are looping through that. And that physical entity has its own unload content method. Unload content. There we go. We can do that ourselves because we have that, we know that class exists. We cannot do it the opposite way because we don't know if you want to load a physical entity or a text entity or a different type of entity altogether. We don't know if you want to load that. For unloading, as long as it has a parent of physical entity, we can unload content. Now, what about text entities, you might be saying? Well, that's the same thing. For each, var text entity in text entities. Text entity has its own unload content as well. Text entity.unload content. Now we will set content unloaded is equal to true. Okay. Now for the update and draw methods. The update and draw methods. This is going to be we are going to we're going to seal the update entity method. And we're going to create a new method that every class will need to override. It's going to be abstract, and that's going to be update screen. Remember, this screen is a game entity. We don't want that to be the reference point from now on. Game entity has an update entity method that is called. We want to seal that, and then in the future, for future screens, that will now, the code that we will need to use, we will need to implement, will now be update screen, not update entity. So, protected, sealed, override, void, update entity. This screen is just an entity. If you didn't see that, I needed to add Microsoft.xNative framework at the top there. And you'll need to add using system.link as well. Sometimes if you just get typing and you have ReSharper, all that's taken care of in the background, and I forget to mention that. The first thing we want to do, entities can be requested to be deleted, just like the screen can. The first thing you want to do before you try to update the entities, if any of them are queued to be deleted, delete them. And that's very easy to do. Entities.remove all. And we'll need to add a predicate. And this predicate, we're going to use a lambda expression for this. E.request deletion. So that's going to remove all entities that satisfy this condition, which is entity.request deletion. If that's true, it will be removed. If it's false, it will stay in the list. So the same thing with text entities. Remove all te.request deletion. Okay. Now, we're going to make things simpler for the other people using our framework. We are just going to provide the list of entities that can be updated. If you have other needs, anything you see here, if your needs differ, you can feel free to change. But I feel like as someone using this framework, just give me the list of entities that can be updated. I don't need to see the list of frozen entities because I can't really do anything with them. I can't update them. So I don't need to worry about looking for that myself. This is supposed to be taking care of that. So var updatable entities is equal to entities.where, another lambda expression, not e.isFrozen. So this is going to get a IEnumerable of every entity that is not frozen, which means they are updatable entities. var updatable text entities is equal to text entities dot where te arrow not te dot is frozen. All right. So we got updatable entities and updatable text entities. Now let's call update screen. Let's pass game time updatable entities and updatable text entities. And we have not created that method yet, so that's fine. Let's go ahead and do that right now. Protected abstract void update screen. Game time. A list. That's another thing that I want to talk about. These are IEnumerable. Entities.where, that returns IEnumerable. Again, this is another thing that is if you document it well, it doesn't matter which way you do this, but I like to convert this to list. It takes some performance hits up front, but I do not know what I'm going to do when I implement BaseScreen or implement other screens. I do not know what I'm going to do 20 games from now. I might loop through this list 100 times. I might, for some reason, for unknown reasons right now, but for some reason down the road, I might want to add something myself to that updatable list or remove something from that updatable list. So I like to convert those to a list. So that's going to be a list of game entity, and that's going to be updatable entities, and a list of text entity, and updatable text entities. All right, that moved it to a new line, and that's good. Okay. Same thing with drawing. The same thing we did for updating, we want to do the same thing with drawing. So protected override void draw entity. Game time, sprite batch. We need to add using Microsoft.xnay.framework.graphics. Sprite batch. Alright, let me scroll down here, move my mouse. Same exact thing, except we're not going to remove anything. So, var drawable entities is equal to entities.where lambda not e.isHidden .toList var drawable text entities is equal to text entities.where lambda te not te.isHidden .toList. We're going to call draw screen game time sprite batch drawable entities and drawable text entities. Let's go ahead and create that method now. It's just going to be the same thing as update screen. Protected abstract void draw screen game time sprite batch list of game entity drawable entities and list of text entity drawable text entities. Okay, so the last thing we want to do is we want a way to add an entity. These are protected. So by default, it's going to be protected get only as well. We want to have a public way to add entities. Public. And the reason we're doing this is we have one method. At this time, text entity is a game entity. So we're just going to have one method. Game entity. That is going to determine what list it goes into. That way, the user won't have to call, all right, for these entities, I need to call add entity. For this entity, I need to call add text entity. It just, as of right now, a text entity is a game entity. So there's no point to have these methods split. Var text entity is equal to game entity as text entity. Oops. Semicolon. If text entity does not equal to null, we will set text entities.add. We will set this as a text entity. Else entities.add game entity. Alright, so that's it for this video. I hope you enjoyed it. This is actually take 2 of my video for this. I'll explain in the looking back why I had to redo this video. But I hope you enjoyed this video and stay tuned for the next ones. And I'll see you next time.